Hello, this is Mr. Henry, and welcome to lesson 6.2. Today's lesson is talking about solving inequalities using multiply or divide. The last lesson we talked about, we were using addition and subtraction. You're going to find for the most part, this lesson is kind of the same, except with multiply and divide. So the essential question says, how do I solve inequalities using multiplication or division? We've got three get the goofs there. So let's see what mistakes we can find. Number one, it says 2 plus r is less than 8. Well, if we would minus 2 here and minus 2 there, these would cancel out. We'd get r is less than 6. Everything's good so far, so this is correct. Now let's see if the graph is correct. You put this number in the middle, bigger, smaller, so the number line's correct. We would need a hollow dot at 6, which we do not have a hollow dot. We need a hollow dot at 6 because this is just less than. It is not or equal to. So we need a hollow dot at 6, and we'd be shading that way. So this is now correct with a hollow dot instead of a solid dot. Number 2. Let's see, t minus 2. So we'd add 2. These cancel out. This would give us 10. One thing I'm not liking here is everything got switched in the middle of the problem. So let's keep it the way it was. So it should be 10 is less than t. Then we would switch it. So we'd flip-flop the sides. So t would go here, 10 would go there. But they forgot to switch the direction of the inequality. You've got to switch everything. The variable, the answer, and this inequality. So it should be going this way, which would mean when we graph it, we got the 10 in the middle, bigger, smaller, hollow dot. Yeah, when we graph it, the arrow should be facing this way, because now t is less than 10. Okay, and number 3, let's see, you would add 9 to get rid of a minus 9. M equals, well, 23 plus 9 is 32. And then m is less than or equal to 32. Well, first off, we would have the number line's wrong. So let's just get rid of him and do it properly. So we put 32 here, getting bigger, getting smaller. We would have a solid dot because we have this or equal to line. And the arrowhead would be facing to the left because it is less than, or using the arrowhead trick, it's pointing to the left, you shade to the left. Alright. So we have the same vocab word from yesterday. An inequality is just a math problem where the two sides are not equal. One side is greater than the other. What I'd like you to do, though, is take a minute, pause the video, and try to write down the circles and each of their circle types. Think about the inequality from yesterday, or the lesson from yesterday. What were the different circle types and their inequalities that go with it? Go ahead, pause the video, do that, and we'll get back together in a second. Okay, so you should have had something like, for less than and greater than, you get a hollow dot. For less than or equal to and greater than or equal to, you get a solid or filled in dot. So these two have that, these two have that. The way you can tell is the or equal to line makes it solid. The not or equal to is hollow. Okay? Now, there's only one difference you're going to find in solving these inequalities versus equations. There's one small trick that's going to happen, and it only happens when you multiply or divide by a negative. We're going to see that in letter C is the first problem we're going to see this trick happen. So let's get through A and B, see how they're just like normal, and we'll see how letter C is different. So letter A, it says B divided by 8 is less than 13. So the way you get rid of A divided by 8 is you times by 8. Times by 8. These guys cancel. B is less than or equal to 80 and 24 is 104. Could always double check it though. 13 times 8. So our 104 goes in the middle, getting bigger, getting bigger, getting smaller, getting smaller. We need a solid dot at 104 because we have the or equal to line, and we are going to shade to the left. B is less than 104. This way is less than, or using the arrowhead trick, because the variable's on the correct side, it looks like an arrowhead pointing that way. So you shade that way. Letter B. So here we have negative 84 is greater than 7w. Okay, so the opposite of multiply is a divide. So we're going to divide by 7, divide by 7. These cancel out. W is less than, let's see, negative 84 divided by 7. It's going to be a negative something. Negative, I don't know. 84 divided by 7 equals 12. So we got a negative 12. Before I do anything here, my variable is on the wrong side, so I'm going to flip-flop everything. So w goes here, negative 12 goes there, and I change the direction of the inequality. This is the one I'm going to graph from. So we put our negative 12 in the middle. Getting bigger is negative 11. It's bigger. Negative 13 is smaller because it has more negatives. Negative 10. We need to put a hollow dot in the middle because this does not have or equal to. So hollow dot. And we're going to shade w is less than negative 12. We're going to shade less than. Now, here's where we get a difference, letter C. You might not notice a difference here in letter C, how it's different than the rest of the problems. But here it is. The rule states that when you multiply or divide by a negative, you change the direction of the inequality. I'll say it again. When you multiply or divide by a negative, you change the direction of the inequality. So when we solve this problem, the first thing we're going to need to do is divide by a negative 4. We're dividing by a negative 4. As soon as you do that, in the middle of the problem, this inequality has to change. It's when you multiply or divide by a negative. And now this answer gives us a positive 4. Before we go through the rest of the problem, let me show why we did not change it here. Because a lot of people look at this and go, look, well, we divided by a negative 84. And no, we didn't. We divided both sides by a positive 7. So we divided by positive. Here in letter A, we multiplied by a positive 8. So positive, letter B, positive. Letter C, we divided by a negative 4. The thing we did to both sides was negative. That's why we changed the direction of the inequality. Now, we graph. So 4, getting bigger, getting bigger, getting smaller, getting smaller. We need a solid dot. By the way, the rest of the problem is just the same. Solid dot. And we shade greater than to the right. So the one thing that's different, when you multiply or divide both sides by a negative, you change the direction of the inequality in the middle of the problem. There will be problems out there, we'll see it I think maybe next section even, where you have to change the direction of an inequality multiple times in the same problem. It's okay. Just do it each time and you're fine. Letter D. D divided by 7. So the way we get rid of a divide by 7 is we have to times by 7 on both sides. Now, because we're multiplying by a positive 7, nothing changes. It's just the same. And we get 21 here. Number line, 21, getting bigger, getting bigger, getting smaller, getting smaller. We need a hollow dot at 21 because there's no or equal to. So hollow dot, and we're going to shade to the right. And that's the problem. Okay, so we've done 4 examples here. There are 4 problems I'd like you to try. So these are letters E, F, G, and H. Please pause the video, copy them down, do the problems, hit play, and we'll go through them together. Okay, so let's see, letter E. Well, you would divide both sides by a -5. You're dividing by a negative because the thing next to the variable is negative. So we get D. We have to change this direction of the inequality. Hopefully you did. If you forgot something, it's probably that. And that gives you -8. Alright, and you got -8, getting bigger, getting bigger, getting smaller, getting smaller. We need a solid dot at -8 because we have the or equal to line. So solid dot at -8, shaded to the left. Letter F. My variable is being divided by -5, so the opposite is to multiply by a -5. Multiply by a -5. Now, we multiplied by a negative, which means we changed the direction of the inequality in the middle of the problem. A times -5 is -45. And we're done. Okay, so -45, getting bigger, getting bigger, getting smaller, getting smaller. Hollow dot, and shade to the right. Letter G, we are going to divide both sides by 3. We're dividing both sides by a positive 3. So the sign of the inequality does not change here. I don't care this other number is -12. The number I'm doing on both sides is a positive 3. But I am going to change this because the variable's on the wrong side. So I want to switch this because I want the variable on the left, so I switched this and that, and then change the direction of the inequality. 4, -3, -2, -5, -6. Those are bigger, those are smaller. We need a hollow dot at -4, and we're going to shade to the right. And last of these, letter H. X divided by 4. Okay, so we're going to times by 4. Times by 4. And that gives us x on this side is greater than or equal to a -8. Again, the inequality did not change because we did not multiply by a negative. We multiplied by positive 4 on each side. So there's -8, and then getting bigger, -7, -6, -5, oh, not -5. Smaller than -8 is -9 and -10. We need a solid dot at -8, and we shade to the right. Now, before we move on, just one thing I want to mention here, popped in my brain, is we have a whole bunch of examples now of this hollow dot and solid dot thing. And let's be a bit more clear on why we have them. Here in letter H, if I plugged the -8 in for x, would this be a true statement? Is -8 greater than or equal to -8? The answer is yes. -8 is the or equal to part. It's equal to negative 8. So negative 8 is a solution to this problem. If I plugged in any other number here that was shaded in, so if I plugged in, say, a negative 5, is negative 5 greater than or equal to negative 8? Yes. Even if I used a positive number like 3, 3 is greater than or equal to negative 8. So this number is an answer, along with everything else that's shaded. Okay. Over here in letter G, negative 4 is not an answer. Watch. If we put negative 4 here and plugged it in, is negative 4 greater than negative 4? No. Negative 4 is not greater than negative 4. It's equal to. So negative 4 is not an answer. So this is like a little force field saying negative 4 is not an answer. But if I plugged in any other number that's shaded here, if I plugged in negative 3, is negative 3 bigger than negative 4? Yeah, it is. Even these numbers like right here, close to negative 4, like negative 3.8, is that bigger? Yes. Okay. So that's important to know why we have these hollow dots and these solid dots. And it comes up again later on in this chapter in a different form as well. There are 4 problems in the textbook I'd like you to try. These come from page 356, numbers 4 through 7. Go ahead and pause the video, do them up here on the board, and we'll get back together shortly. Okay, so hopefully you've done these 4 problems, and let's see how we did. Letter number 4 here, we would, it's being divided by negative 4, so I would times by negative 4 on both sides. These cancel. We get x. Because we multiplied by a negative, we change the direction of the inequality, and that gives us a negative 48. So negative 48 is the answer. I'm going to skip a number, but 47, negative 46, negative 49, negative 50. So I'm still counting by ones. I'm just not going to cram all those numbers in there and make it look a little ugly. And I need a hollow dot at negative 48 and shaded to the left, less than negative 48. So that's number 4. Number 5 we'll put over here. There's number 6, number 7, 4. All right, so here number 5, we would multiply both sides by a negative 7 to get rid of the divide by negative 7. M, change the direction. I don't know that off the top of my head. It's going to be 70 and 52 is like 102, something like that. 1.6 times 7, 111. 11.2, and it would be a negative. So you put your 11.2 here, negative. You know what? Let me show you another way to do this graphing. Let's put a, we're going to only put whole numbers on the line. So let's put, we'll call a negative 11 here, negative 10, negative 12, negative 13, negative 14. All right, so we got just the whole numbers. Now, negative 11.2 would be like here. So we're going to put our hollow dot there and shade this way. And then all we need to do is just label this point as negative 11.2. That way we know exactly where this dot is at. Because this dot's a pretty big dot. And so if you don't put a label inside, we don't know exactly where we're at. Or you can put the label down here if there's space. I like this method a lot for when you have decimals. Okay? That's number 5. Number 6. We're going to divide by 5 on both sides. That one's easy. V is greater than or equal to 9. 9, 8, no, 9, bigger, 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 bigger. 10, 11, 8, 7. I've been so used to doing negatives the past couple problems. We need a solid dot at 9, and we're shading to the right. Number 7. Divide both sides by negative 6. You heard it. We're dividing by a negative, so we change the direction of the inequality. And that gives us a -4, -3, -2, -5, -6. We need a hollow dot at -4. So we're going to put our hollow dot here, and then we have a greater than. So we're going to shade greater than, which is to the right. Arrowhead trick. Looks like an arrowhead pointing to the right, so you shade to the right. So that is graphing inequalities with multiplication division. All that's really left is just some application problems of that. So let's see here. Example 2. It says your school wants to buy lollipops as a fundraiser. They cost 50 cents each. Write and solve an inequality that shows how many lollipops a school should buy or could buy if they have $350 to spend. Oh, how many lollipops could the school buy if they have $350? Yeah, I got it. So they have $350, and the lollipops are 50 cents each. And you want to know how many of these things can you buy. So 50 cents times each lollipop, we'll call it. So 50 cents times each lolly. And can this amount be more than 350, less than 350, equal to 350? I mean, this is going to help us get our inequality in there. Well, if you have $350 to spend, you don't want to spend more than that. So you'd want this stuff, the amount you spend on the lollipops, to be less than or equal to 350, right? So 50 cents for each lollipop times the number of lollipops. So if you bought 2 lollipops, 50 cents times 2, you spent $1. If you bought 5 lollipops, you spent $2.50. All right, so that's how this comes about. And we want that total amount we spend to be less than or equal to $350 because that's all the money we have to spend. So this is kind of like our verbal model to a degree. It's more of a math problem. And then let's make it an actual math problem. Get rid of the word. So 0.50. I'm going to use P for pops. I don't like using L because it looks like a 1. So P for pops is less than or equal to 350. And to solve this, the way we have to get rid of the 0.5 is we divide both sides by 0.50. Divide by 50 cents on each side. And P is less than or equal to, it's going to be 700. 350 divided by 0.5. It didn't work right. 350 divided by 0.50, if you really want it there, equals 700. So the lollipops could be less than or equal to 700. So you could buy 700 lollipops or anything less than that, and you'd be less than $350. So if you bought 600 lollipops, you're good. You did not spend more than the budget. If you bought 705, now you're over the $350. You have to buy less than 700. Okay? Pretty simple, pretty self-explanatory, I think. Letter B. A lumber mill is cutting up a tree. How big of a tree would they need if they wanted to cut it into sections 5 foot long and they wanted to have more than 10 sections? Well, I can tell you right now, anytime you're cutting something up, that's usually a division problem. If you have a pizza and you cut it up into 12 slices, you're dividing it into 12 slices. Okay? If you have a rope and you cut it up into 3 pieces, or into, so many pieces, and each piece has to be 5 foot long, you're dividing it into pieces. Okay? So we have our tree, and we're dividing it. We're cutting it. And we want the thing after the cut. Let's see, how big of a tree would they need if they cut in 2 sections 5 foot long? So they're cutting the tree into 5 foot long sections, and they want to have 10 sections. I was going to write 10, but we'll do the number 10. Okay, so there's a tree. You're dividing it by 5. You're cutting it into 5-foot long sections, and you want to have more than 10 sections. So you want this thing, the tree divided by 5 feet, you want this to be bigger than 10 sections. This is our verbal model. Tree divided by 5 feet sections. You want this to be more than 10 sections. How big of a tree would they need if they want to cut it into 5-foot long sections and they want to have more than 10 sections? Okay, so that's how we came up with the inequality using this verbal model. Now we can take this guy and we can translate it in. Whoa, that was interesting. Take him and turn it into an actual math problem. So tree divided by 5-foot long sections is greater than 10. To solve this guy, we're going to multiply both sides by 5. These cancel out, and t is greater than 50. So you'd want a tree that is bigger than 50 feet long, or feet tall. That way you can cut it up into those 5-foot sections and have more than 10 of them. All right. Letter C, I'd like you to try on your own. Go ahead, pause the video and do. It says each blue rupee Link collects is worth 5. How many blue rupees could Link collect? How many blue rupees could Link collect and be able to buy the Kokriki shield that costs 40 rupees? Go ahead, pause the video, do it on your own, and when you're ready, hit play and we'll go through it together. Alright, I fixed the typo in there, and let's see how we do. So each blue rupee is worth 5. So that means you're basically doing repeated addition. 5, 5, 5, 5, 5, 5. That's multiplication. So I'm going to take the rupee times by 5. So each rupee, here we go, we'll do this. Haha. There. Each blue rupee times by 5. That's how much it's worth. This is the worth of it. So if I collected, for example, like 3 of these, 3 times 5, I'd have 15 rupees. Okay, so the rupees times by 5. And I want to be able to buy this shield, or Link wants to be able to buy this shield that costs 40 rupees. So he needs to have at least 40. He can have more than 40, but he can't have less than. So he wants this stuff, the number of rupees, to be bigger than or equal to 40. That way he can buy the shield that he wants. So now that we have our little, well, kind of a verbal model, it's actually an equation. You'd use like an R for rupees or something like that. So now we divide both sides by 5, divide by 5, these cancel out, and rupees is greater than or equal to 8. So he has to collect at least 8 blue rupees to be able to buy the shield. Because if he gets 8 of them, 8 times 5 is 40, he can afford the shield. Okay? Summary. We're done. How do you know when you have to switch the direction of the inequality? There are 2 cases. There are 2 times now that we've learned when you switch the direction of the inequality. What are those 2 times? Pause the video, really think about it, write it down, and we'll go through it here in just a second. Alright, so the 2 times that we've learned to switch the direction of the inequality, one happens when you multiply or divide by a negative. So and that's what we learned in this lesson here today. So like negative 3m is less than 9. When you divide by negative 3, these switch the direction of the inequality. So that's one case. The other time you switch the direction of the inequality is in your answer. If the variable's on the wrong side, you switch it. So if variable is on the wrong side, an example might be if you have like negative 5 is less than g. To graph this, the variable's on the wrong side. So I'd want to switch the g and the -5, and then you switch the direction of the inequality. Those are the two different cases we've learned to switch the direction of the inequality. And hopefully you came up with both of those answers. And homework comes from page 366, 10 through 22 evens, which is not that many problems. It's like 6 problems. And then number 32. All right. This has been lesson 6.2. Thank you for watching.